of your textbook. Okay? And it simply says, find the coordinates, which in real life, it would be find the position, find where this thing is if t equals 2. So think of t as 2 seconds. So after 2 seconds, where is our ball going to be located? Well, his x-coordinate's going to be 6, and his y-coordinate's going to be 9. So that's the position, x comma y, of whatever this thing is if we let t be 2. Could we do the same thing if we let t be 5? Or 18? Yeah. So if you did all the t's, if you thought of all the possible t's, you'd get all the possible points, and you'd know what this picture looked like if you were to graph it, right? Now our calculator will graph these, and we'll talk about that later. This next problem, this is like number 5 or something, number 5, yeah, number 5, says 3 things. Gives you parametric equations. These are your parametric equations. And it says, okay, find the points when t is everything from -3 to +3. So it's like having a t-chart, literally, where you got t values, and then you're going to find x and y values, and these are going to be your ordered pairs. So if t is -3, x would be -6, and y would be -10. So our first point is 6, -10. I see some blanks here. This is really simple. All you do is plug in the t value. So we put in -2, and we would get -4, -7. That would be our ordered pair. And they're just asking you to do that all the way till you get to t equals 3. So you're just going to keep on doing that. And finally, you're going to plug in 3 and get 6, 3, 8. And you'll be done. Just getting a bunch of points. Then part B says, this is a little bit more complicated, but still not hard. Part B says find a direct algebraic relationship between x and y. And what that means is get rid of the t's. Write one equation instead of 2, write one that has just x's and y's. Now, does anybody have a thought on how we might accomplish that? Solve for t and plug it back in. So that's one option. So maybe in this first equation, t would equal x over 2. Everybody okay with that? So then if I took that and plugged it in here, my equation would say y equals 3 times x over 2 minus 1, which is the equation written another way, 3/2 x minus 1. What is that the equation of? If you were going to sketch that, that would be a line. So these two parametric equations gave you a ton of points, right? And if you graphed all those points and connected them, you would get a line. Pretty easy. So let's talk about another strategy to do that. Because it sort of depends on what your equations are like as to which way is easier. Will this always work? Absolutely. Sometimes, though, it's easier to, I said sometimes it's easier. I'm not telling you have to do it one way or the other. This will always work. If that makes sense to you, use it. But sometimes it's easier to solve them both for t. So in other words, t equals x over 2. And let's see if I did this one. T equals y plus 1 over 3. And if you do that, if you solve them both for t, then what can you do with these guys? Set them equal to each other? And then you would have, I mean, it's not cleaned up yet, but it would be the same result. You have one equation now, and the only variables in it are x's and y's. And that's what this means. So it's when it says in those directions to number 5, it says write a direct algebraic relationship. That means write one equation that has just x's and y's with the t's. And you can do that, you know, however it works best for you. And then graph what's left. Well, you should have no trouble graphing the line that's left. What can you tell me about this line? It has a y-intercept at -1, and it has a slope of 3/2. So I'm going to count up 1, 2, 3 over 2, and there is my line. Okay, now get your calculators out, and I'm going to show you quickly how to do this on the calculator. Okay, so what I want you to do first is I want you to go to your window, and I have no idea, since you just did that regression problem, your window might be messed up. So let's just use a standard window, -10 to 10 for the x's, and -10 to 10 for the y's. Okay, then I want you to go to mode. Press the mode button. And one of the options, if you look, is PARAM. Or PARA, I'm not sure which one it is. You want that one. That's your parametric mode.
Would it be just PAR?
PAR, yep. Parametric.
Where? Under function.
So you highlight that. Now we're going to parametric mode because we're going to type in these parametric equations. We have already decided we're going to get a line that's going to look like that. So we're going to see if it works. So we're going to type in, when you hit y equals, when you hit y equals, it pulls up x equals and y equals, right? So you're going to type 2t. T is on your variable button, where you used to press it and it gave you an x. Now when you press it, it gives you a t because you put it in a different mode. Okay? Then put in your y equation, and then hit graph, and you should see that line. Okay, so you can put in whatever equations you want into parametric mode. Now, listen, you're going to loan your calculator to somebody in another class, and he or she is going to try to type in an equation right now, and it won't work. If you want to type in a regular equation, then you got to go back to mode and put it back in function mode.
Why is it all squiggly? Is that right?
I don't know why it's all squiggly. Oh, it's just plotting. Yeah, we got some kind of setting on there. It's just plotting a bunch of points, I think. Okay, so we understand that to make our calculator work normally, we're going to have to change it back to function mode. Okay. All right, good for that. Now, would you open up your books if you haven't already? And we're going to look at problem number 10 and 11. Because we have a little bit of vocabulary to talk about. Problem number 10 looks sort of like a sine curve. It's shifted a little bit, but now the question, let's go through the questions. Is this a function?
Yes.
Absolutely, it's one of our BFF, basic family of functions. This is a function. We can tell something is a function because it passes the vertical line test, right? Okay, now I want you to think just a minute about a couple of points on this graph. This would be the point pi over 2, comma 1. You are supposed to know that. This would be the point negative 3 pi over 2, comma 1. And would there be another point out here that had a something, comma 1? And another one back here, there's lots of them, right? That are something, comma 1. That's not a problem for this function. However, we're going to start talking about the inverse of the function. And the inverse of the function reverses the ordered pairs. It undoes. So what was x turning into y becomes y turning into x. It undoes. Okay? So these ordered pairs, if I did the inverse, these ordered pairs would turn around and become this. The inverse switches the ordered pairs of every function, not just this one, every function. The inverse switches the ordered pairs. Okay, now look at these ordered pairs. Would that be a function? No, because the x's are repeated, right? So this would not be a function in this case. Now, this was not a function because Taylor said the x is repeated. But in the beginning, it was the y's that repeated, right? So when I switched the ordered pairs, then they became the x's and they repeated. So when somebody says to you, is the inverse a function? Is the inverse a function? You want to check the y's of the original. So let me say this again. It's not confusing, but sometimes it is when you say it. I got a picture. Somebody says, is it a function? You check the x's, right? Vertical line test. You check the x's. If I say, is the inverse a function, you're going to check the y's, and that's the horizontal line test. If a function passes both vertical and horizontal, it is called one-to-one. So an example of a one-to-one would be your cubic function. Does it pass the vertical? Does it pass the horizontal? That means it is a function and its inverse is a function. Okay, you can't wait to get the heck out of here. Have a great rest of the day. Hope the test went well, except for that one bad question.